Okay, so welcome to this video where we're going to solve question 1 to 4 of tutorial sheet 2. Okay, so question 1 to 4 on what we call as binary operations. Okay, so a binary operation can be any operation, okay, between two or more numbers. Okay, so in most of the cases, a binary operation is represented by a star like this. Okay, so this star here will be defined based on what you've been given in the formula. So a binary operation can mean addition, it can mean multiplication, it can mean subtraction, it can mean division, okay? Or it can mean anything that is being defined by the formula, okay? So when we go to number 1 here, you can see they're saying determine whether or not each of the following definitions of this star, which is given below, gives a binary operation. Okay, in the event that the star is not a binary operation, give justification for your answer. Okay, so how do we test that a certain operation, in this case, this star here, is a binary operation? Okay, so we use what we call as the closure rule. Okay, so if, for example, you've been given a set of natural numbers, okay, so we know that the set of natural numbers starts from 1, 2, 3, 4, until forever, okay? So the counting numbers, the set of natural numbers start at 1 and then it goes on forever. So if I get a binary operation, this star here, okay, and I test it on this set here of natural numbers, okay? This star here is only a binary operation, okay, if it obeys the closure rule. So what is the closure rule? It means that, let me say my binary operation define A star B, okay, to be equals to A plus B. Okay, so A star B will mean A plus B. So if I pick any two numbers in this set of natural numbers, A and B, let me say my A is 1, and then my B is 2. Okay, when I pick these two values here from the set of natural numbers, okay, their sum, or after I apply this binary operation, the number that I should get should also be a natural number. Okay, so here you can try, you can say 1 star 2. This will just give you what? 1 plus 2, which will be 3. So now you ask yourself, the answer that I'm getting, is it also a natural number there? Okay, so we can see that 3 is a natural number. Okay, so if you get two individual elements of a certain set, and then you apply a binary operation, and then their final answer there is also in the same set where you got these two numbers here, then it will mean that that operation you've applied is a binary operation. Okay, so always when we are testing, if something is a binary operation, we are going to be using this closure property, okay, which states that whatever the binary operation state should also be in the set where you are getting those two individual elements. Okay, so now let's solve this. So they're saying a set of Z plus. Okay, so Z plus indicates the set of what? Positive integers. And we know that the positive integers will just be 1, 2, 3, 4, until forever. Okay, you don't expect any fraction here because these are integers. So those numbers on the number line, but on the only the positive numbers. So we are given this one here as our binary operation. Okay, so we are given that R star S is actually equals to RS minus R squared. Okay, so let's put it here. Okay, so we are given on this set of positive integers, we are given that R star S is just equals to the multiplication of R and S, okay, and then minus R squared. Okay, so we can say you can pick any two numbers, two elements of this set. So let's say my S is actually a 3, and then I mean my R is a 3, and then my S is let's say 2. Okay, so we see that these two numbers here, okay, the 2 and the 3, they are a member of what? The positive integers. So once I get these two numbers and I apply this operation here, is my answer also going to be in that set? Okay, so if it will be in that set, then it will mean that the operation is binary. If it won't be in that set, it means that the operation won't be binary. So let's test these two values. So here where there's R, I'm going to put 3, and then star. Where there's S, I'm going to put 2. Then this will be equals to the R there is the 3 multiplied by the 2, which is the S, and then minus the 3 squared like this. So what do I get when I multiply this? So here you get 6, and then minus 9. Okay, so we see that the answer that I'll get here is a minus 3. Okay, and then you ask yourself, is this minus 3 part of this set of positive integers, we see that the -3 will not be a member, okay, will not be a member of the numbers of the positive integers here, okay? So since after applying the binary operation, the answer that I'm getting is not in this set, then we conclude that our star here is not, okay? So you write in capital letters, is not a binary operation. So just write BO. Star is not a binary operation. So that's how you prove. Okay, so we are done with the first question on A. Let's look at the question on B here. Okay, so is this guy here a binary operation? Okay, so the answer there is no. Why? Let me show it here. Okay, so we are on the set of all real numbers, and then we are given A star B, okay, is actually equals to A to the power B. So is this answer always a real number? The answer is no. It can be a complex number. Okay, so let's choose my A to be, let's say -2. And then let's say my B is a half. Okay, so this would mean that I have a -2 star half. Okay, this will be equals to -2 to the power what? Half. And we learned that half here is just the same as the square root. Okay, so this will be the square root of what? -2. And we see that the square root of -2 is not a real number. It's actually a what? It's a complex number. Okay, so we can write this as the square root of 2 multiplied by the square root of -1. Okay, the square root of -1 here. Okay, and then this will be square root of square root of 2 multiplied by, what is the square root of -1? Okay, so these are complex numbers. So square root of -1 is actually equals to I. Okay, so here I'm just going to say I. So this is the same as I, the square root of what? 2. And we see that I, the square root of 2, is not a what? A real number. Okay, because it's a complex number. Therefore, this star here is not, okay, it's not a binary operation. Okay. Okay, so what is C saying? So C here, we're saying on the set of all the integers, meaning the negatives and the positive ones, defined by A star B is equals to A minus B modulus there. So is this star here a binary operation? So let's test. Okay, so we are on the set of all the integers. Okay, and then we have A star B is actually equals to the modulus A minus B. So we see that the number that we'll be getting here will always be a positive number. So we can say let my A be 4. Okay, so you can pick any integers of your choice. And then let my B be a -2. And then let's apply that binary operation. So I'm going to say 4 star -2. Okay, and then this should give me modulus of 4 minus, what is my B? -2. Then like that. Okay, so this will be the modulus of negative minus multiplied by negative, that will be +2. Okay, so this will be 6. We see that my answer there would must what? Will just be 6. Okay, so you ask yourself now, is this number that I'm getting also an integer? Okay, like that, Z. Okay, we see that yes, okay, 6 is an integer. Okay, so 6 is a member of the what? The integers, like that. So meaning that the star there is a binary what? Operation. Okay, let's look at D. So D, what does it have? It has on a set of what? Okay, on a set of natural numbers. Okay, defined star by A star B is actually equals to A multiplied by B divided by 5. So natural numbers, I already said those are counting numbers. So 1, 2, 3 until forever. So we are on the set of natural numbers, and then we are saying A star B is defining A multiplied by B divided by 5. So is this star a binary operation? Okay, so let's test. So let me say I get my A as 2, and then I get my B as a 3. Okay, so I test these values here. So it will be 2 star 3, okay, which will just be 2 multiplied by 3 divided by 5. And then this will be 6 divided by 5, which will be 1 over 5. Okay, so you ask yourself now, is this answer that I'm getting a part of the natural numbers? We see that it's not, okay, because we can't find any counting number that is a fraction there. Okay, so meaning the star there is not a binary operation. So it says star is not, okay, a binary operation. Okay, so that's how you can solve questions on question 1. I have solved all of them. So let's go to question 2. Question 2. Okay, so they're saying for each binary operation star. Okay, so here they have given you that this is a binary operation. Determine whether this star is commutative or it is what? Associative. So how do you do that? Okay, so you have to know the meaning of what commutative is and what associative is. Okay, so let me go to my board here. So if they say a certain binary operation represented by star is commutative, okay, what do they mean? Okay, so if they say this star is commutative, then they mean that A star B, okay, should actually be equals to B star A. Okay, so if they give you a certain formula, they ask you to check if it's commutative. You just have to check that A star B is equal to B star A here, not star C. Okay, so you change the positions of these guys. So here we started with A, here we're starting with what? With B. And then you check if they will give you the same thing. That will be commutative. And then associative, it means there we have 3 elements. Okay, associative. I don't know if that's the correct spelling. So there it means we have 3 elements. Okay, so we have A star, B star what? C. And then this should be equals to A star B, then star C. Okay, so on the first one, we're going to put the brackets on the A and B. And then on the second one, we are going to put the brackets on the B and C. So if this expression that I have here is actually equals to this expression that I have here, then it will mean that that operation is what? Associative. Okay, so now let's test. So the first one there that we were given on A, we're given to test A star B is actually equals to A squared minus what? B squared. Okay, so we want to test that. Is this star here, okay, commutative? Oh, was this the first one? No. I think the first one had no squares there. Okay, so it's just A minus B there. Okay, so let's remove these squares. So we want to test that this star, is it commutative or is it what? Associative. So what are we going to do? Okay, the approach is similar. So this one here, they have said on the set what? The set of integers like that. So we are testing on this set of integers. So we are going to pick any 2 integers from here and then check if the commutative property holds. So we are going to say, let A be, you can choose any integer, guys. So I'll choose my A to be 2, okay? And then let me choose my B to be a minus 3. Okay, we know that 2 and minus 3, they are integers, okay? Okay, so let's apply these 2 and see that, see if the commutative property is actually holds. So I'm going to draw a line here, and then here I'm going to put A star B is actually equals to A minus B. And then on the other side, I'll put B star B, B star A is actually equals to. So when you reverse these guys, it means even the first one here should be B and then minus what? A. So let's apply these 2 guys here into this. So here should be 2 combine B. I'm supposed to put -3 there. Okay, so 2 star minus 3 is actually equals to 2 minus 3. So we see that this one is going to give us what? A 5. What about this guy here? Okay, so here to be -3 star what? 2. So this will give us -3 minus 2, which will be what? A -5. Okay, so here we've seen that A star B is 5 and B star A is -5. So this means that A star B is not equals to B star A. Okay, so what does this mean? It means that the binary operation star here is not commutative. Okay, it's not commutative like that. Okay, so that's how you show it. Okay, and then let's show if it's associative. Okay, so when you're showing for associative, you have to introduce a third letter there. So this one should be A star A, B star A, not C. Okay, so for associativity, let's write our operation again. So A star B is actually equals to A minus B. Okay, so for associative, you always have to introduce a third letter, even if it's not given here. You just have to introduce it. Okay, so we said our A was 2, our B was what? -3, and then we are going to introduce a third letter, which is C, and then just say that C is what? Is 1. Okay, so what do we want to prove? We want to prove that A star B and then star C is actually equals to A star B and then star C. Okay, so you can see that on this one we have the brackets on B and C, and then on this one we have the brackets on A and B. Okay, so this is the operation that we are going to be applying, guys. Okay, these guys are going to be changing here, but we're going to be following the same expression. So if I have C here where there's A, it means here I have to put C. If I have D here I have to put D, just like that. So you first always start with what is in the what you have in the brackets there. Okay, so we know that A star B means A minus B. So A minus B is just 2 minus 3. Okay, so this is what we have, and then we say star. What is our C? 1. So this will be 5 inside there. So 5 star 1. So we have 5 star 1. We are going to use this same expression here on top. So our A is 5, our B is 5. I mean, our A is 5, and then our B is what? 1. So this here, okay, so this here simply means 5 minus 1, which will give me what? A 4. Okay, so we've shown that if I have A star B in brackets, star C, my answer is just 4. What about if I have the B and the C in the brackets? What am I going to get? So we're going to put 2 star -3, and then star what? 1. Okay, so you always start with what is in the bracket. So this is going to be 2 star, and we know the operation that we are applying. So this one is acting as our A here, the -3, and then the 1 is acting as our B. So meaning this will just be -3 minus what? 1. Okay, so we see that this will actually give us 2 star. This will be -4. Okay, then we have another operation that we have to apply here. So this 2 is now the A, and then the -4 is now the B. So this one, if we apply this operation here, it's just going to be 2 minus -4. And we see that this is just going to be what? 6. So we can see that what we have on the left-hand side and what we have on the right-hand side, they are not equal, okay? Therefore, this operation here is not what? Associative. Not associative, but that's right, ASS, okay? Don't have any bad thoughts in your head. Okay, so this operation there is not associative. All right, so let's check the other one. So that was A, and then let's check B. So B, we have a set of Q. So what is a set of Q? So Q, they are just what? Rational numbers. Okay, and we know that rational numbers are just numbers that you can be expressed in the form of A over B. So it means all the fractions. Okay, all the fractions are what? Rational numbers. Okay, so let's check if this operation here is commutative or it's associative. Okay, so let's go to the board. Okay, so we are on B now. We are on the set of rational numbers. And then we have this binary operation here where they're saying P, Q is actually equals to P plus Q divided by what? Divided by 2. Okay, so this is how the binary operation is being defined. Okay, yeah, I have a flu, guys. So bear with me. Voice sounds sourish. I don't know. I have a flu. So since this guy here is, we're talking about the set of rational numbers. So we can pick any 2 rational numbers from this set. So for simplicity, I'm going to pick my P as 1, because we know that we can write 1 as 1 over 1. So this is a rational number. And then Q, I'm going to pick it as 3. Okay, I know that I can write this over 1. This will be a rational number. And then to test associativity, we are going to include a third letter there, which will be R, or any letter of your choice. Okay, and we are going to say this is what? 2. So we are going to use these guys here to test, okay, for commutativity and associativity. So let's start with associativity. So I'm going to draw 2 lines. So associativity means that P star Q should be equals to Q star what? P. All right. So what is our P? Our P is 1. Okay, remember this is defined by P plus Q and then divided by 3. Okay, so this will be 1 star 3 is actually equals to, yeah, so they are supposed to put 2 here down, not 3. Okay, so this will be 1 plus 3 divided by 2. So this will be 1 plus 3, which is 4, divided by 2, it will just be 2. Okay, so what about this side? So this will be defined as Q plus P divided by what? By 2. So I'm getting my Q as 3 star 1 is equals to 3 plus 1 divided by 2. We see that this is also going to give us what? 2. Okay, so we can see that the P star Q is actually equals to the Q star what? P. So what does this mean? It means that the symbol star is commutative. Okay, so mutative or mutative like that. Okay, let's prove the associativity property. Okay, so I'll draw a line here. And then we want to prove that P star Q, okay, star R is actually equals to P star Q star R. Okay, so I said you always start with the brackets if you have to. So we know that P is 1 and then Q is 3. Okay, so this here is just going to give us 1 plus 3 divided by 2. And then we are going to stay star. We let our R to be what? Remember our R was 2 here. Okay, so we are going to put 2 here. So this is just going to be 2 star what? 2. And we know that by the binary operation that we have here, this simply means that I have 2 plus 2 divided by what? 2. So this is going to give me, this will be 4. Divided by 2, it will still be 2. Okay, so this guy here is given as a 2. And then what will this give us here? So we start with what is in the bracket. So my P is 1 star, and then my Q is 3 star, the R which is 2. Okay, so we know that by the binary operation, okay, so by the binary operation, what I have in the bracket simply means 3 plus 2 divided by what? By 2. This is the star here. Okay, and then this will be 1 star. What is 2? 3 plus 2. 3 plus 2 is 5. And then that 5 divided by 2 to be 2.5. Okay, and then we know that if I have something like this, it will just mean 1 plus 2.5 divided by 2, based on the definition that we have there. Okay, so this would be like 3.5 divided by 2. Okay, we see that this can't equal 2. Okay, can't equal 2. So this will be 1.75. So we see that what we have here is just 1.75. So this guy here is not equal to that guy there. So it means my star here is not what? Associative. Not associative. Okay, so not associative there. Okay, let's prove the third one, and then I'll leave the other two for you guys to try. I'll leave the other two for you guys to try. So math is about solving. You need to practice. Okay, you need to practice. All right, so let's look at this guy here. See, we have that. We have a set of rational numbers, Q, and then A star B simply means A squared minus B squared. So is that associative, and is it what? Commutative. So we have that A star B is actually equals to A squared minus what? B squared. Okay, so we are on the set of rational numbers, so we can pick fractions there. So A, we're just going to say my A is 1, because I know 1 over 1 is a fraction. B, I'll say 2, because 2 over 2 is a fraction. And then I can also pick C to be 3 when we're testing the associative property. So let's test if this is true. So we want to test that A star B for the commutative property is equals to B star what? A. Okay, so let's draw a line here, and then let's put A star B here. So A star B actually means A squared minus what? B squared. So this will mean what? So it will mean that we have A star B is equals to 1 squared minus what? 2 squared. So this will be equals to 1 minus, this will be 4. Okay, and then the answer here will just be minus 3. So are we also getting a minus 3 if we do B star A? So B star A will just be B squared minus what? A squared. So this will be 2 star 1. So this will be 2 squared minus 1 squared. So this will be 4 minus 1, and going to give us a 3. Okay, so we see that A star B is not actually equals to B star A. Okay, so meaning the star there is not commutative. Okay, not commutative like that. Okay, and then what next do we have? Okay, so let's prove the associativity. So associativity, we want to prove that A star B star C, okay, is actually equals to A star B and then star what? C in the brackets. Okay, so we know that this will be 1 star 2 then star 3. This should be equals to 1 star 2 star 3. Okay, so will this be equal? So A star, 1 star 2 will just be 1 squared minus 2 squared. Okay, we can put this in brackets and then you say star 3 is actually equals to, this will be 1 star, start with what is in the brackets. So that will be 2 squared minus 3 what? Squared. Okay, so meaning this one here will just be 1 minus 4, which will be a 3. Star 3 is actually equals to 1 star. This will be a 4 here, okay, because 2 squared is a 4 minus 3 squared. Why did I write 3? So 3 squared will be a 9. So 4 minus 9 will be a minus 5 there. Okay, so we have a minus 5 there. Okay, so let's apply the operation on these two. This will be 3 squared minus 3 squared. You can see that this will give us a 0. And then here it will be 1 squared minus 5 squared. Okay, so it will mean here I'll get a 0. And we see that a 0 is not equal to 1 minus what? 25. So here we have 0 is not actually equals to minus 24. Okay, so it means that that operation there is not associative. Okay. All right, so I think I've done enough for you guys to get the idea. You can try out D, you can try it E. On D here, they missed the set here. That's supposed to give you the set, okay? So you can try to ask for clarity there from your lecturers. Okay, let's go to number 3. So number 3 is the simplest in this tutorial sheet. Okay? So we have a binary operation being presented in a table, okay? And what does that mean? So it means the method that we're going to be using here to find the answer is the same. If you remember that multiplication table that we had some time back, where you had 1 to 10 here, 1 to 10. And then when you're doing 1 times 1, you get 1. 1 times 2, you get 2, just like that. You remember that multiplication table? So it's similar to what you've been given here. But in this table, our binary operation is not a multiplication, okay? So that multiplication table is an example of a binary operation in which the binary operation is just the times sign. But in this side, in this table, the binary operation there is meaning something else. So if I do 1, okay, 1 star 1, my answer should be 1. 2 star 1, my answer should be 1. 3 star 1, my answer should be 1. 4 star 1, my answer should be 4. What if I do 5 star 3, okay? So you just come where these guys were going to cross, okay? So 5 star 3, it is this value here, which will be what? 1. So that's the method that we are going to be using. Okay, so let's evaluate or find the value of this guy here. So find the value of 3 star 3 star 4 star 4. Okay, so 3 star 3 on this table, what is it? So I go to 3 and then I say star 3. So where are these two guys meeting? They are meeting here. So it is the 3. So 3 star 3 is just 3. And then I have star. And then I check 4 star 4. So 4 and then star 4 is giving me what? A 4 here. You can see it. So it will be 4. Okay. So the final answer there will just be 3 star 3 star what? 4. So let's find 3 star 4. So I can go on the 3 here, and then I say star, and then I go on the 4. So where are these two meeting? They are meeting on 1 here. Okay, so they are meeting here. So 3 star 4 will just be 1, according to the table. Okay, so this is the answer here. Okay, and then B, they're saying, is set A commutative? Okay, so we said commutative, we must find the same thing if you swap the value. So if I find 4 star 1 here, 4 star 3, is it also going to give me 1? So you go on the 4 and then star 3, Okay, so you come here, what is it giving you? It's giving me 1. Okay, so since 3 star 4, 4 star 3, they are giving me the same thing, then we can say that set A is what? Commutative. All right, so that's one method of finding it. But if you don't want to use that method, there's another method that you can use. So you just have to draw a diagonal here. Okay, that cuts these numbers in the main diagonal. Okay, starting where the sign is, you just draw a straight line here. I'm going to draw a straight line that passes through those guys. Okay, so this straight line that I've drawn here, and then you start checking the numbers that are there. Okay, so the numbers that are there should always be the same. So you can see 1 and 1. I have 1 and 1 again. I have 1 and 1, 1 and 1. I have 2 and 2. I have 1 and 1. 1 and 1, 1 and 1. Then I have 1 and 1 again. Okay, so if these two opposite numbers here are always the same, okay, when you draw this line, then you can say that the data that you've been given there, or the set that you've been given, is commutative. Okay, so that's another way you can find it. Okay, so we are done with this question. So it was the simplest here. No thinking when you're doing this question. Okay, then the last one, it's this question 4, where we are saying we're given a binary operation, this small 0 like that, okay, is defined on the set of all real numbers as x with this 0y, okay, is it just equals to x plus y minus 3xy. Then they're saying if this symbol here is commutative, okay, so if that is commutative, then it will mean that x 0y is actually equals to y 0x. Okay, it will mean this. So they are giving us it here. They are not telling us to prove. They are giving us that this guy here is commutative. Okay, if you want, you can prove it. You will find that it is commutative. Okay, and then they are saying find the identity element and the inverse of this symbol here. Okay, so what is an identity element and what is an inverse element? Okay, so an identity element is just an element where if you get an element and you apply a binary operation with that element, okay, the answer should just be the element that you have. Okay, so let me show it. So if I have this element and then I apply a binary operation 0 with an identity element that I'll say is being represented by E, then my answer here should be the same element that I started with. Okay, so in short, an identity element doesn't change anything. Okay, so a good example is on addition. When you're adding, a good example of an identity element is 0. So if you say 2 plus 0, it will give you what? 2. I say 4 plus 0, it will give me what? 4. So you can see that an identity element here doesn't change the value here. Okay, so if I have an identity element here and I'm applying this binary operation here, then the answer should just be what? X. Okay, so let's do that. So we are saying we have this binary operation here, which means that I have x plus y, then minus 3x what? Y. Okay, let's find the identity element for this guy here. So what are we going to do? We are going to select the identity element. I'll just write IE here, identity element B. Okay, we can say E or any data of your choice. Okay, so it means that if I get this operation here and I apply this guy here, okay, I should get the same element that I start with. Okay, so let me start with my x. So if I get my x and I apply it with an identity element, then my answer should just be what? The same x. Okay, but we know that if I have x 0, something here, it actually means this. Okay, so this guy here will actually means that I have x plus e, okay, minus 3x what? E, from this definition. So we are just replacing wherever there's y here, we have put e, guys. Okay, and this should be equals to what? The x. Put the like terms together. Okay, so we can see that on the left hand side, we can factorize the e from these two. So we are going to have 1 minus 3x. Okay, and then this should be equals to x minus what? X. So this will simply mean that my e, 1 minus 3x, is actually equals to what? To 0. Okay, and then you divide by 1 minus 3x on both sides. You're going to get your identity element to be what? To be 0. Okay, so my identity element in that case, we are still finding as 0. So you can check it. So if you say x 0, 0, this will be equals to x, okay, plus 0 minus 3x, and then multiplied by 0. So you can see that this would just be x, and then here 3 multiplied by x by 0 just be 0. So we can see that 0 is indeed a what? The identity element, because it's giving us back the element that we have started with. Okay, so that's how you find it. And then the inverse, okay, the inverse is such a number that when you apply it with a certain element, okay, it's going to give you the identity element. Okay, so remember we found the identity element to be 0. Okay, remember our binary operation states this plus y, this minus 3xy. Okay, so what is an inverse element? So an inverse element, if I put an inverse element here, it means the answer that I should get there should be the identity element, which is 0. So I'm going to say let my inverse, okay, let my inverse element be, we can say P, because I'm tutor Poul anyway. Okay, so let my inverse element be P. It means when I do X, 0P, okay, I should get what? The identity element, which is 0. So we're going to use this equation. But we know that X, 0P here will just mean this guy here. So wherever there's Y here, we're just replacing with P. So this one will be X plus P minus 3XP. Okay, is actually equals to what? To 0. So we are solving for what? For P, because P is our inverse element. So we are going to say what? We are going to say minus 3XP is actually equals to, and then we take these guys to the other side. Okay, so okay, no. So this P here is still here. And then we can take the X to the other side to be minus X. And then from here we can factorize the P. So it will be 1 minus 3X is actually equals to minus X. Then let's divide both sides by 1 minus 3X to find the P. So our P, which is the inverse element, will just be minus X divided by 1 minus what? 3X. Okay, so this will be our inverse what? Element. So if you try to put this, okay, into the binary operation with the X there, you see that it will actually give you a 0. Okay, it will actually give you a 0. Okay, so let's try it. So if I get X, 0P, okay, and the P is what? Let's put the P here. So the P, which is the inverse now, is minus X, then over 1 minus 3X. Okay, so the first thing here, we're going to say, if we apply the same binary operation, to be X minus, plus, minus X divided by 1 minus 3X, and then it will be minus 3X multiplied by minus X divided by 1 minus what? 3X. So does this give us a 0? Okay, so you can add, guys, you can add. So this guy plus this guy to just be, the common denominator will be this. Okay, so this will be over 1. So 1 into this, it will be the same. So X multiplied by this, it will be X minus 3X squared. And then this guy into this, it will be 1 multiplied by minus X, it will be minus X. And then on the other side, I have minus 3 multiplied by X multiplied by minus X. It's going to give me a plus 3X what? Squared. And then I have 1 minus 3X. Okay, and then this will be X minus X, it will just be 0. And then here I have minus 3X over 1 minus 3X. Okay, so this is squared, and then plus 3X squared over 1 minus 3X. Okay, so we see that when we add this, we're just going to get 0. Okay, so we have proved it. Okay, so but in your answering, in case it comes in the quiz or the test, you don't have to show this part. Okay, I was just showing this part so that you understand. All right, so we are done with the 4 questions. Okay, next time we'll continue from question 5 and solve all these questions all up to question what? Question 19. Okay, so thank you guys for watching. Those who are interested in our tuition services, okay, I'll put a number in the link for this video. Okay, so if you want to register for tuitions, our tuitions are online and they are very effective. We have videos on almost everything. Okay, you are free to contact us on that line, and then you can join the winning team. Okay, so thank you so much. Have a blessed day and all the best in